Okay, it should be to you now, Daniel.
Okay, cool. So I hope everybody can hear me. Like Dr. Irvin said, my name is Daniel. This is my third semester doing or being an SI leader. So I have a lot of experience, and a lot of different activities that we're going to be able to do throughout the sessions. That's going to be what SI is going to be focused on. It's going to be kind of like different activities where we can better learn the material that we just talked about in the lecture, or do practice problems that are going to be based off of what y'all might see on the test. So that's basically what SI is going to be. What about the scheduling that I want to talk about? It's just a link that I sent y'all, I think in the email already, and then also in the group me. I sent y'all a link to go take a Qualtrics survey, and through there we can try to identify what times work best for the most amount of people to go to the session. So that's all I really have to say about that. Everything else should be good to go, but thank y'all for listening. Cool.
Okay. All right, over back to me. What I'm going to do is I am going to just go through some of my administration, but then I'll go off to my sharing of my slides and we'll go for there. Okay, as you should have already received, you will get an email each Monday, and that email will have what's due that week. Okay, so we have a different Zoom meeting scheduled for each week, and that's partially just for to keep me on track, making sure I have things scheduled, and partially that, you know, if we do end up having some academic dishonesty or Zoom bombing, we will change that. And if it becomes a problem, we'll have to get a pass word associated with it. But right now, I think everything's been moving very smoothly, and I hope we continue doing that. So in that email, I should have what chapters we'll be doing that week, the Zoom code for that week, the homework that'll be due that week, and I'll talk a little bit more about homework in a minute. This week we have a mock Top Hat exam, okay, and that's on Wednesday afternoon. Basically, that's to make sure you and your system are working correctly. You should have received an invite from Top Hat. Top Hat has the week's homework in it, and all of our exams will be administered through Top Hat, okay? It requires you to have a working webcam. So if you don't have a working webcam, you need to find access to a working webcam to be able to do that. If you are having difficulty with that, email me privately and we will try to find a solution, okay? So the Top Hat will require you to only have Chrome, Google Chrome, and you must download the Proctorio application or plugin for that. And so everything will be run through that plugin. It has a nice little intro into how it works and what it's supposed to do. And so it'll actually let you do some preliminaries, testing your system to make sure that you have enough bandwidth and that you have the right settings on your phones and stuff. Okay. So that's Top Hat. And so go ahead and try to get that all set up this week. Homework is due on midnight on Thursday, okay? You will have approximately 10 to 12 problems per chapter. They're due on midnight at Thursday because you'll have 2 attempts to get the correct answer, and then it'll be graded at that point. So we have that grading. After midnight, it's released for your review. You can go back and look at that homework, see what you did right, see what you did wrong, and try to go back and have time to study before the exam on Friday to get that straight in your head so that you can perform well on the exam, okay? So any questions about homework or Top Hat? Go ahead and either chime in or, okay. The homework, it'll be in the email every week, by the way. Homework is due at midnight on Thursday. Immediately after that, it'll be available for review. You'll see what you got right, and you'll have unlimited attempts to figure out what the correct answer is, okay? Top Hat, a lot of people have already signed in. It should only be $30. Correct me if I'm wrong on that. We're using it for homework and exams only. We have no quizzes, and all of our other things will be done on Zoom. I can actually present and lecture through Zoom, but I prefer to do it with the system I'll be using today. And so we'll do that as needed. Okay. Can the link yes. What I will do is anybody who joined the class today, after this class, I will go in and make sure everybody gets a new invite. If you haven't already done it, you might, if you've already signed up, you might get another invite, but I just want to make sure everybody's on there. One thing you might have to do is you have to have a Texas state ID. So if you're transferring in, you need to make sure your net ID is active to be able to get that invite. And so if you just transferred in, go ahead and send me an email to make sure I invite you to the Top Hat. Okay. Okay, let's see. So as far as Top Hat goes, again, we will also be using that for exams. All exams will be on Friday from noon to 1:40 p.m. That's during our regularly scheduled time, except for our final. Our final is going to be issued at our standard final time, which is 2 to 4:30 on August, I want to say 5th or 6th. It's in the syllabus. I'll double check that. I'll give you a week's warning before we get there. Okay, let's see. So I've answered a question about Top Hat, exams. The homework for week 1 will be posted this afternoon, and you will have until Thursday afternoon. After this week, all homework should be available to you by Friday. You should have the rest of the homeworks for the rest of the year. So that should pop up this thing. Okay. So for the mock test, no, the mock test is not graded. It's just to make sure your system is operating and you have everything you need to be successful taking the exam on Friday. So there won't be any kind of grade. As far as participation goes, we will have a partial participation grade as we go forward. We have group activities on Thursday afternoons, which I'll talk about in a minute. And there will be, well, SI sessions are not mandatory. Your participation is encouraged and will be, attendance is taken. So we will know that you're participating in that system. But there's no direct grade for that. Let's see. And all of our tests and homework will be formatted the exact same way. So. Okay.
Hey, Dr. Irvin, I had a fast question about, so this is my first semester using Top Hat as a service. Could you elaborate a little bit on how the homework will go? Like, is it short answer questions that we have to write, or will it be multiple choice that we submit? Or?
Okay. For the most part, they're going to be multiple choice questions. I'm working with Top Hat over the summer to actually change the book a bit so that we can actually have drawing questions. It is not going to be as difficult as Sapling. Sapling was very particular about how you put everything in there. It's going to be more multiple choice. All of our drawing examples will be done on our group activities. Okay. Does that answer your question?
Yes, sir. Thank you very much.
I actually had a similar question.
Yes.
I actually have the homeworks open in a separate window right now.
Mm-hmm.
And for some reason, it's showing just homework week 1 and enter your text here with nothing else.
Correct. I have not posted those questions yet.
Oh, okay.
So yeah, all of that will be posted by this evening. So you should see approximately 10 questions for chapter 12 by this evening. I'm still defining which ones I want to use for that. Okay.
Thank you.
But in future weeks, they will all be available to you much earlier. It's just I had to make sure that my whole class was online very quickly. So, okay, let's see. I will be posting in Tracks and on Canvas which chapters we'll be doing. For example, this week we'll be doing chapters 12 and 13. And so that's where we're going to focus our attention this week. And I do have an outline of when each week's chapters will be, and that will be posted today as well. Okay.
Dr. Urban, I had a question.
Yes.
So I looked at your YouTube videos that you uploaded today, and it said chapters 17 and 18.
Correct. Chapters 12, 1 and 2 are already up. Chapters 12, 3 and 4 will be up this afternoon.
Okay, thank you.
As well as this. This is what we're going to call it. This is going to be dated by our class. The date in A is before our break, and B will be after our break. Okay. So, okay, wow, 58 out of 63 students. That's amazing. Okay, so that being said, okay, so going through again the email each of you will be receiving. If you didn't receive that email that says Chem 2342.751 Org Chemistry 2 due this week, please send me an email. I need to get you on the list to make sure you are apprised of what's due this week. Again, we'll have new Zoom meeting each week. We have the homework and top hat for chapters 12. It's 12 and 13. Sorry, I have 11 and 12 there for some reason. I think it's 12 and 13. Content. I know we did chapter 11 last semester. So, okay, so it should be chapters 12 and 13 due this week. Yeah, 12 and 13 is due this week. So that's what the email should say. I apologize. Our mock exam is on Wednesday. It's just to make sure your system's working. Our first group project will be a Zoom project on the second half of Thursday's class. I'll send out instructions and what we'll be doing and how to turn it in on Thursday. And so what we'll do is we'll have our normal lecture at the beginning of Thursday's class, and then break, and then come back in. And then I'll divide you up into groups in breakout rooms. And then you work the project through in small groups of between 4 to 6. And then Daniel and I will go in from room to room and answer questions as necessary. But that's what our group project is. The group project is typically some kind of multi-step working through a synthesis or something, using what we've learned this week to kind of reinforce it in our heads about the selectivity of reagents, the reactivity of substrates, and the multi-step synthesis that we will be building to get us very adept at the organic chemistry. Okay. Let's see, then our first exam over chapters 12 and 13, I will resend the email with the correct times on there. It will be from noon to 1:40 p.m. If you do have ODS accommodations, please go ahead and email me that. I will have a separate sign-in for you for that. So just go ahead and communicate that with me, and I will be able to accommodate your needs for that. Okay. Let's see, are there any assignments we need to worry about aside from the Thursday homework? The Thursday homework is the only thing that has to be technically due by midnight. The Thursday afternoon activity, you will have to upload your answers, but I also will provide an answer key so that you can use that as another study tool. There will be, let's see, homework, exams, and activities are the 3 major portions of our grade, and there will be a participation grade toward the end there. I'm still working out the actual details on that with that. It's not going to be a major portion. It's just to make sure that we have something in there. Also, there is a syllabus that's mostly accurate on Tracks and on Canvas right now. I forgot to publish my Canvas site, so it is published now. And so you will be able to go there, and I will apprise you of any changes that might happen on those. Okay, so let's see. That is all the things that'll be due this week. And so again, if you have not received an invite from Top Hat, or you just signed in, please go ahead and send it to me. Tracks and Canvas should have exactly the same information. This semester, I'm transitioning over from Tracks to Canvas and making sure I can do both things in both places. So you should be able to use either one for that. for information and grading. One thing I want to talk about in Tracks is Tracks has the added bonus that we have discussion section in Canvas. On Canvas, there's a discussions page. On the discussions page in Canvas, there's already 3 discussions laid out. One is problem solvers. That's where if you're having like problems with Top Hat or something, you can ask other students to how they overcome their problem with whatever, or hey, this homework question isn't working, is it not working for you? That would be in the problem solvers section of discussion under Canvas. Then there's a cyber lounge, and that's just for, you know, other comments that you would have there. Again, these discussions are public, so be careful about what you say there. However, I'm not going to, you know, monitor them or anything. And then there's a third discussion section, which is called Zoom Study Group Finder. So if you study better in a group, you can go ahead and set up your own Zoom meetings. You can put things like in the study session, hey, I want to study chapter 12 at 3 p.m. on Wednesday. Anybody have time to do that? And so that's where you would post that, and then you can set up your own Zoom meeting and go ahead and invite your people to that Zoom meeting to get to there. So I highly encourage you to, you know, either meet people in your SI sessions that you feel you can study with, or go to the random, you know, the Zoom meeting finder and just say, hey, I have time this time. Does anyone want to? I highly encourage you to, you know, talk about this amongst yourselves. I won't have access to those Zoom meetings. You can just talk amongst yourselves and hopefully get an idea about what, you know, who works great in your study group, and so that you can, you know, exchange info and be social and study and learn. There shouldn't be anything different in Tracks or Canvas except for the discussion section, which is only found in Canvas. Okay. So because I'm not on campus, I don't have a phone. And so the best way to contact me is through email. I will try to get back to your emails as quickly as I can. And if we need to talk about something in great detail, what we can do is we can set up a private Zoom session, and we can have office hours and other things through that. Obviously, I could have set up office hours, but it might be better for us to set up individual office hours. If it turns out a lot of people want to meet at the same time, I can set up a group office hours for a small group of up to 5, and we'll set that out. This class is a little bit, this is my largest class that I've taught online so far. So if I have to do that, I will. But for now, I want to go ahead and try to set up individual meetings if at all possible. So there is no requirement to participate in SI sessions, and there is no added bonus for going to there. We just feel that it is such a strong learning tool that you should use it as an opportunity to gain information. Okay. So I believe I've answered all the questions in the group chat so far. So what I'd like to do now, okay, as far as homework grades will be as is, and I will curve the finals based on how the class is doing. And I'm sorry, I will curve each exam as they go. I'm trying to target a certain, you know, average on the exams around 75, so that if it's higher or if it's lower than that, I'll curve it up. If it's higher than that, I'll keep it as is. So, okay, that being said, let me see if I can get my iPad to share my screen. Come on. It's trying not to share my screen. Let's see if it's doing it now. There we go. All right. So you should be able to see a slide that says Chapter 12, Alcohols from Carbonyl Compounds now. Okay, I'm going to move the video window up here to see if I can spread it out and see as many of you as possible. Here. There we go. Okay, and I have multiple pages. Wow, that's good. All right, so Daniel will be monitoring the chat to make sure I answer your questions as necessary. And so there is a PDF version of the book going around there, but I can't distribute it, just so you know, somebody out there does. Okay, so let's go on and start talking about Chapter 12. As a preliminary here, we need to remember that, you know, what we did in chapters 1 through 11. And so we need to remember our functional groups. We need to go back, and I will put out a review on tracks and on Canvas about, you know, the top 3 things you need to remember about NMR, the top 3 things you need to remember about IR, because we'll be using those, and those will come in handy toward the end of the class, but we will be kind of going over those a little bit here and there. And so one of the things you can do is, you know, go back and review those things, but I will have a review on both Canvas and tracks to get us going on that. So there we go. So good, it's sharing with me. Okay, so let's just get us back into the mindset of organic chemistry here. We're going to talk about, in the last part of the last semester, we talked about alcohols, and we talked about making primary and secondary and tertiary alcohols and how we did that. So in Chapter 12, what we want to do is we want to say how we can make alcohol from carbonyl compounds. Now, if you remember, back in Chapter 2, we went over all the different classes of these compounds, including the carbonyl-based compounds. And so that is what we'll be starting with here. So to start with that, we need to first remind ourselves what the carbonyl compound is, or the carbonyl group is. And the carbonyl group is the carbon double bonded to oxygen. And so depending on what's bonded to that carbon, it actually changes the functional group. So if we have that carbonyl bonded to a carbon and a hydrogen, we have our first functional group we're going to talk about, which is our aldehyde here. And then if we replace one of these hydrogens with an R group, we have our ketone. If we take that hydrogen and oxidize it off, we'll end up with a carboxylic acid. And once we have this carboxylic acid, as we'll have an entire chapter on this, by the way, as we go forward, we'll be able to make all of these different functional groups out of there. Okay, so the key here is that the carbon-oxygen double bond is the carbonyl, and it sets the stage for the reactivity for the rest of the semester. Okay, so we're going to see that carbonyl play a role in almost every chapter from now on, except for the aromatic rings. Okay, so one of the key features with this carbonyl compound is the fact that it is polar. Okay, so our carbon is sp2 hybridized. That means it's trigonal planar, and we have that 120 degrees between the groups bonded to it and that double bond to oxygen here. Okay, so that sets the structure of the material and says that it's planar, but it also has the difference in electronegativity between the carbon and the oxygen leads to its reactivity. We're going to see that polar bond is where all the reactivity happens, okay? And so let's talk about that polarity here. If we look at the resonance structures associated with it, our purest one here is where the electrons are perfectly shared and there's no charge at all. And then the other extreme is where those charges are separated completely. We have a full negative charge on the oxygen and a full positive charge on the carbon here. But of course, as we know, as we remember from resonance hybridization, we know that the true state is somewhere in between. And so what we like to say is that the oxygen up here is partially negative and the carbon is partially positive, okay? So with that partially positive carbon of the carbonyl, that's where we're going to do the reactions to. That's the reactivity we're going to focus on here. Okay, so what are we going to do with that? Okay, so the first thing we're going to do is a reaction with a nucleophile. Okay, and if we remember, a nucleophile is any Lewis base that can either have just a lone pair or a negative charge. Right here, it's looking for positive charge. Nucleo meaning plus, phile meaning loving. It's looking for positive charge. Okay, so if we look at our carbonyl structure here, and it could be any old carbonyl structure. Let's just draw an aldehyde here. This is our partially positive side of our so that our electrons from our nucleophile are going to come in and create a new sigma bond and do that addition. When it does this, it kicks up the electrons and gives us a negative charge on our oxygen. And so we end up with going from an sp2 hybridized carbon to an sp3 hybridized carbon, okay? And it generates that new sigma bond, okay? So that's gonna be the key feature when we're looking at reactions with those nucleophiles, is we're gonna go from an sp2 to sp3 hybridized carbon. So look for that. But again, it's tacking that partially positive charge. The other set of reactions we have related to these carbonyl compounds are what we call oxidation reduction reactions, or in short, we call them redox reactions. Redox, right here, from reduction oxidation, okay? So in these reduction oxidation reactions, we typically go in between the same two states here. We're going in between the sp2 hybridized and sp3 hybridized carbons. So in the case of oxidation, we're going from an sp3 hybridized carbon to an sp2 hybridized carbon, and we're gaining that carbonyl, okay? So notice we're losing 2 hydrogen in that oxidation reaction. That's the key, okay? And we'll talk about that in a minute, okay? But if we were to want to reduce down this carbon and take it the other direction, and so we can actually, that carbonyl compound can be reduced back to the alcohol in the reduction process, okay? So the oxidation is going from an sp3 hybridized carbon to an sp2 hybridized carbon. The reduction is going from an sp2 hybridized carbon to an sp3 hybridized carbon, okay? Let's talk about oxidation reduction a little bit more. In inorganic chemistry, we typically think about it as the gain or loss of electrons, okay? So in the case of oxidation, oxidation is the loss of electrons, okay? So going from a neutral species to a positive species is oxidation. Reduction is the gain of electrons. That's going from a positive species to a less positive species, okay? So that's inorganic, okay? So what we want to focus on is looking at it from an organic perspective. From an organic perspective, we look at it a little bit differently, okay? Oxidation is increasing the number of bonds to nitrogen, oxygen, or a halogen. So halogens are just anything X, which is fluorine, bromine, chlorine, etc., okay? And it typically involves the decreasing number of bonds to hydrogen, okay? So you can think of it as increasing the number of bonds to nitrogen, oxygen, et cetera, or decreasing the number of bonds to hydrogen. That means reduction is exactly the opposite. We're going to be increasing the number of bonds to hydrogen or decreasing the number of bonds to oxygen and nitrogen. Okay, so what does that look like? Actually, let me change my width here. So if we had a CH3 at the end of a long chain, and we just wanted to go ahead and say, okay, can we reduce this compound anymore? Well, technically, the only thing we could do to reduce this anymore, to add any more hydrogens, is to reduce it down to methane, okay? That's carbon with 4 hydrogens on it, right? So what we'll do is that's the only reduction we could possibly use. So what I would instead want to do is look at oxidizing it. So if we were to just oxidize this, Okay. What we would do is we'd have to decrease the number of hydrogen bonds and add a bond to a nitrogen or oxygen. So in this case, what I'm going to do is I'm going to take away one of the hydrogen bonds and put on an oxygen bond. Okay. So now we have oxidized this carbon right here by adding that oxygen bond, and we've decreased the number of hydrogen bonds by one. Okay. So if we were to go in the other direction, that would be our reduction right here. And we typically do reduction as the addition of hydrogen because we're adding a hydrogen carbon bond. Okay. So we could then, well, we can still oxidize this a little bit more. We can take away one more hydrogen bond to carbon and oxidize it even more. So let's do that. And that would generate, oops, not that compound. This compound here. We're just going to take off one of those and then put the electrons that were between the oxygen and hydrogen in there to create our new carbonyl compound. That's the next oxidation step available to us, okay? And we can also reduce that from the aldehyde down to the primary alcohol in this case, okay? Or we can even oxidize it one more time. We take off that last hydrogen bond and we add another oxygen to it, creating another oxygen bond to create one of our most oxidized functional groups, which is the carboxylic acid. Okay. So when we do this oxidation and reduction step, we'd like to keep track of how oxidized or reduced our carbon is. So we actually assign our oxidation state to our particular carbon. And the way we do that is we go ahead and assign anything that is more electronegative than carbon, like oxygen, nitrogen, sulfur, and any halogen. We add +1 to each bond that is more electronegative than carbon, okay? So for anything that is less electronegative than carbon, like hydrogen, lithium, and magnesium, we assign that number -1, okay? And carbon-carbon bonds do not oxidize or reduce, therefore they don't take into account in the oxidation state, so that's 0, okay? So that being said, the lowest oxidation state material has to be carbon with 4 hydrogens on it. Okay, because then you would have a -1 for each of those hydrogens, and you would have an oxidation state of -4 for methane. Okay, now let's do the same math, but instead let's do ethanol right here. So here we have 2 carbons, and these 2 carbons are in 2 different oxidation states. Okay, so let's talk about these. Now, if we remember from our nomenclature, and I'll have a memory thing there, this is our number 1 carbon, and then this is our number 2 carbon right here. So let's talk about our number 2 carbon first, because it's easier. Okay, we have a carbon here with a carbon-carbon bond, so we get 0 assigned to that. And then we have 1, 2, 3 hydrogens. Each hydrogen gets -1. So that means our number 2 carbon has an oxidation state of -3. Okay, so let's assign our oxidation state for our carbon 1. Okay, so we have a -1 for this hydrogen, a -1 for this hydrogen, but we have a +1 for this oxygen here. Okay, so that means we have a -2 + 1 makes the total oxidation state for the carbon number 1 equal to -1. Okay, so that's each and every carbon in our system has an oxidation state assigned to it. Our lowest being methane at -4. Our highest would be something like carbonic acid, which would have an oxidation state of +4. But let's make sure we're doing our rules right, and let's do formic acid here. Okay, remember we assign +1 for each bond to an electronegative atom, a more electronegative atom. So I'm going to change over to green right here. So we only have one carbon here on here. So let's look at what's bonded to that carbon. We have a hydrogen. So we have a -1 for the hydrogen. We have a +1 for the OH, okay? And we have 2 bonds in our carbonyl here. So we have to have +2 for that carbonyl oxygen, giving us a net formal charge of +2, okay? So our oxidation state on the carbon in formic acid here is +2. And again, if we oxidize that down to the carbonic acid where we take this hydrogen off, we'll end up with our +4 oxidation state. Okay, so that's how we measure oxidation and reduction in organic compounds, and that's how we track our oxidation state on carbon. It's not just electrons, it's about each bond to a more or less electronegative atom. And it's 0 for carbons that are the same. Okay. So that being said, now we know that we can change that oxidation state by moving it up and down. And so let's do a little bit with that here. So we have a bunch of different functional groups we just talked about that are related to the carbonyl compound. And one of them is the carboxylic acid. Then we also have the other electronegative atom other than oxygen, like chlorine. Or we have also a carboxylic acid derivative, which would have an ester, or we could have an aldehyde, okay? All of these have just a carbonyl and some other electronegative atom or hydrogen on here. If we did reduction on any of these compounds with a reducing agent, and reduction is a lot of times just done this bracket of an H in brackets here, we're going to reduce all of these compounds down to a primary alcohol. Okay, so all of these compounds reduce down to a primary alcohol, and that allows you to get to anything associated from these carbonyl compounds to your regular. Okay, however, if we started with a ketone, because that carbon-carbon bond is really hard to break, if we did a reduction on a ketone, those carbons are going to stay bonded to that, and we're going to end up with a secondary alcohol when we reduce down our carbonyl compound. Okay, so we can make primary alcohols and secondary alcohols from carbonyl compounds using oxidation and reduction. Okay. All right, so how are we going to do that? Okay, well, we're going to use a reducing agent. Okay, and so when we have reducing agents, you can use like palladium on carbon, but that's going to reduce down all double bonds and triple bonds. So we have 2 different reagents available to us to do selective reduction of just the carbonyl compound. Okay, and the first one we have is called lithium aluminum hydride. Okay, so in lithium aluminum hydride, we typically have something like, we can have a carboxylic acid right here, CH3, and using lithium aluminum hydride, and there's 4 hydrides on there. We typically do that as our first step. And in our second step, we typically add acid to dissolve away our aluminum compounds, our aluminum complexes. And what that will do is it'll reduce any of these esters, aldehydes, carboxylic acids, all of them down to.
Sorry to interrupt, but is that H3O or
This,
H2O?
This is H3O plus.
All right, thank you.
Yeah. Let me redraw that right there. That did not work out well. All right, so it'll reduce this down to reducing off the carbonyl, keeping the bond to oxygen, adding 2 hydrogens to to there, and then a CH3. That's 3. So the lithium aluminum hydride is a very strong reducing agent, okay? But it only attacks carbonyls, okay? The actual functional group here is the hydride, which is a hydrogen with a total of 2 electrons in its s orbital, which gives it a negative charge, okay? It'll reduce down aldehydes, ketones, and acid chlorides, okay? But we usually don't use it for that, and I'll tell you why on the next slide. Now, it does react violently with acids, including water and alcohols. Remember, they are on our acidity scale and have have acidic protons. And so typically we do this in ether. So you'll see that the reactions are written LAH and ether, okay? Because the ether does not react with that system, and then we can quench the reaction with something like, oh, that's acetic acid, ethyl acetate, to quench the reaction, okay? So the key here is that we can take any carboxylic acid derivatives and use LAH to reduce down that carbonyl to give us, in the case of our esters and our acids, a primary alcohol, okay? So what if we don't want to use that? What if we want to use something that's a little bit milder? Well, luckily we have a milder reaction on our series here. And this milder reaction is what we call sodium borohydride, okay? So instead of the hydrides being bound to aluminum, it's bound to boron, okay? And that changes its reactivity and makes it a little bit softer. It's not as strong a reducing agent, which means we can use it in the presence of water and alcohols here. So what that might look like is, if we can have an aldehyde, right here, we can use sodium borohydride, and then that's going to be the first step in the reaction. The second step of the reaction is going to be the same as in the lithium aluminum hydride, where we add a little bit of acid to decompose any boron complexes right there. And that's going to give us also our primary alcohol, okay? But it only works with aldehydes, ketones, and acid chlorides. It does not reduce down carboxylic acids and the esters. Yes, there will be annotated slides uploaded after the class that has them. By the way, I'm answering a question in the box there. Okay, so how does this work? Well, this works because the fact that boron would prefer to have 3 bonds, not 4. So when it's in this thing, it has a -1 charge, okay? So what that means is that since boron only wants 3 bonds anyway, what happens is these electrons that are giving it that negative charge are acting as the nucleophile to react with the carbonyl carbon, giving us our intermediate here, where these electrons come in to make our new sigma bond. These electrons kick up to give us a charge. So we end up with the hydrogen that was already there, the R group that was already there, the oxygen that was already there, and our new sigma bond here, plus, remember this had sodium on it as the positive charge, the sodium salt of the alcohol, which is why we have to add the acid at the end. When we add the acid at the end, we liberate our free primary alcohol, okay? So what does this mean? We have 2 different reagents that are selective about reducing down carbonyl compounds, okay? We have a softer sodium borohydride, which only does aldehydes, ketones, and acid chlorides, and it takes them down to primary or secondary alcohols in the case of the ketones, okay? We also have a stronger reducing agent that will reduce down carboxylic acids, salts of carboxylic acids, and esters, So we have selectivity in this case here. So in the first case, we have a carboxylic acid here, which is harder to reduce than an ester, which is harder to reduce than an aldehyde or ketone, which is harder to reduce than an acid chloride, right here, okay? And what we know about this is that lithium aluminum hydride will reduce all of these, okay? However, sodium borohydride will reduce these, okay? So what does this mean? This means we have selectivity. That's the key when we're looking forward to doing multi-step organic synthesis, is that we have selectivity in what we're doing. So that means that when we have a reaction that has an carboxylic acid or an ester on it and an aldehyde, we can selectively hit that aldehyde with just the sodium borohydride. But not only that, sodium borohydride actually reacts faster with aldehydes than ketones, so that you can be selective within its own compound. So if you have an aldehyde and a ketone on the same compound, you can use sodium borohydride. And if you only use one equivalent of sodium borohydride, you can get it to reduce just the aldehyde to the primary alcohol, leaving the ketone there. Now, if you hit it with a second equivalent of sodium borohydride, it would reduce the ketone down to a secondary alcohol, okay? So the key here is selectivity. Acid chlorides and aldehydes react fastest with sodium borohydride. Ketones are next, and you must use lithium aluminum hydride for the carboxylic acids and the esters. Okay, all right, that brings us to about 12:50. So here I'm going to stop sharing my screen. Okay, any quick questions on this section of 12.1? Okay, so what I'd like to do now is to go ahead and stop recording and stop